hope you can see me. I can't see myself on this camera. I think I'm just going to ask David to do, not David, Cledwin, to do a few housekeeping announcements. Cledwin, do you want to take over for a little bit?
Thank you very much, Jenny. And thank you everyone for joining us today for our technical session. And just a few housekeeping issues. Just take note, please, that the meeting is being recorded. I know a reminder came through when you were joining. So if you're not comfortable with your name appearing on the recording, may you kindly rename yourself to anonymous so that you can remain anonymous. Please take note that there will be a question and answer segment after all the presentations, and all of us will be converted to panelists at that point. So we'll be able to actively participate and engage with each other, which is of vital importance in these sessions, as well as having the good presentations that we know are coming through from our panelists. So those that will be presenting or asking questions, kindly take note that may you please switch on your camera as you present. And any other issues that we'll be having will be communicated via the chat platform so that everyone can see, and we'll be taking note of the questions. Jenny, did I miss anything that is important?
No, I think that seems fine. If we'll just go along, hopefully everybody's got in. It was a bit more complicated getting in, and I think we still might be missing a couple of panelists, but we'll go ahead anyway. So just officially, good afternoon to everybody, and welcome to both our panel members and to all our attendees. My name is Jennifer Broadhurst. I am Director of the Global Challenges Research Fund Mine, Dust and Health Network, we were the ones who've actually organized this technical session in collaboration with the National Association of Clean Air. So just briefly, for those of us who are not familiar with the network, which is hosted by the University of Cape Town and specifically the Minerals to Metals Research Group. This network has been established as an interdisciplinary and multi-stakeholder platform to facilitate a shared and common understanding of the health risks associated with dust emissions arising from mining activities, as well as the opportunities for mitigating these risks. And while these mining related activities include the extraction, the processing, and even the transport of ores, one of the main sources of windborne dust in mining intensive regions are the tailings storage facilities. And this is a particular problem in the Witwatersrand goldfields, which is reported to contain more than 270 defunct gold mine tailings dumps, which remain either totally unrehabilitated or only partly rehabilitated, and which frequently occur in very close proximity to human settlements. And it's for this reason that the GCRF Mine Dust and Health Network has selected the case of windborne dust from gold tailings storage facilities for one of two multi-stakeholder engagement studies. And the specific focus here is on the near to far west Rand shown here on the map. In this regard, the main aim of this particular workshop is to serve as an initial meeting, so to bring together then the experts, stakeholders, and interested parties to share their knowledge and the current understanding around mine dust and gold tailings in this region, and also to identify further stakeholder engagement and research and development requirements going forward. To set the scene for our discussions this afternoon, we have put together a very diverse panel of 7 experts who will each be providing a brief perspective on issues of relevance to this topic before opening up the floor to the broader audience for questions and additional inputs. So in the interest of time management, what I would like to do is go straight into the panel presentations, and I will introduce the panelists as they come up to speak in turn. So let me stop sharing, and we can start off with our first panelist. I don't know, and I did think that David van Beek, he is with us. I thought he was battling to get on. So David is a social scientist and lead researcher of the non-NGO group Benchmarks Foundation. He is very well known for his advocacy of human rights and justice for mining host communities, both within and beyond the Witwatersrand goldfields. And he is going to be presenting the findings of a benchmark study on household health and well-being of communities living close to mine dumps in the southwestern townships of Johannesburg. So David, the floor is yours if you'd like to start sharing your video.
Thank you very much for affording me this opportunity, and let me get straight into it. We did a 3-year-long study in the Soweto area covering the townships of Riverlee, Kipdorp, Netherlands, Snake Park, with a control community in Danville in Mafeking, where there's no mining, but where the economic status and everything else was very similar to the communities that we looked at in the Soweto area. For those who do not know, these townships are all along the northern rim of Soweto and more or less parallel to Main Road, and just south of major mining activity since 1886, when the first mining operation license was given to the George Harrison and where we have now George Harrison Park on the corner of Main Road and Nasrec Road. Now, the location of these townships was historically rather deliberate in the sense that that was the land that had the lowest value, its proximity, its location in terms of wind direction and so on, with the prevailing winds in the Johannesburg area coming from the north and the northwest. Most of the winds blow in a southerly direction, in the southeasterly direction, and straight across these particular mine dumps, and then from these mine dumps into Soweto. And Soweto is in a basin, and really it is one huge dust bucket if one wants to look at it in that way. What we did was we took a template of the World Health Organization, a household health survey, which we then adapted to the South African conditions, and then we took samples in each of these communities, and also, of course, in our control community of Danville. And what we found was quite disturbing. The problems of respiratory disease, the problems of eyes, and problems with skin, eczema and so on, was actually very, very prevalent. And we also found that in some of these communities, particularly in Snake Park, there's a very high incidence of birth deformities amongst children that are born there. And we found similar incidents of these children in Reiger Park, just north of the mine dump outside Boksburg, the old ERPM dump. And we did a study for Save the Children last year when we looked at Belkom. We looked at the Bong Township, which was also on the wrong side of the tailings in that particular community as well. And we find similar problems in all these different communities. We are really concerned because the people of Soweto did not ask to live in Soweto. They were forcibly removed there from 1905 when there was an outbreak in Johannesburg, and the white community of Johannesburg felt that the Asian and black communities had to be moved because they were responsible for that outbreak of the plague, according to the wisdom of the time. And so the first township in Soweto, Kliptown, was formed in 1905 already, but there was never any finance to remove black people out of so-called white areas in Johannesburg until the National Party came to power in 1948, and between 1955 and 1965, all the black spots like Firetown, Doornfontein, and other parts of Johannesburg were cleared out, Brixton and Fortsburg and so on, and all the black people were moved into Soweto during that period. So people did not go there by choice; they were forced to go there. They did not go and live on the wrong side of the mine dumps by choice. They were forced to go and live there among those mine dumps. What we also found, which was very concerning, is that the Chamber of Mines has, since 1994, discontinued its mine tailings maintenance unit, which we thought was a very important unit in maintaining the tailings around the Johannesburg area and preventing the dust blowing from these tailings into communities and so on. And consequently, if we go to the tailings now, most of them are not fenced, most of them are not signposted, and most of them are not properly maintained with vegetation and so on, and not properly watered. And so the dust formation is absolutely incredible. And in places like Snake Park, there are days when between August and November, which is our dust season, where you can hardly see your hands before your eyes. What we are doing at the moment is we are trying to work on a kind of longitudinal study with the National Institute for Occupational Health around River Lee. And we are also trying to get the universities of Cape Town, University of Johannesburg, and Wits University medical science and environmental science departments and so on to become involved in a study to establish the linkages between the illnesses that we found in these communities and the dust from the tailings. Now we've done small studies. We did a documentary with Martin Boudreau, and this documentary has been flighted on Al Jazeera often. And we took hair samples from 5 animals in Snake Park, 5 children in Snake Park, and also dust samples and water samples from the Vlakfontein 352 tailings just outside Snake Park as well. And we found very high levels of lead, uranium, we found silica, we found arsenic, and so on, present in both the human samples, the animal samples, and in the dust samples from the tailings as well. By the way, the animals of the farmers in that community, the pigs and the goats and so on, are born blind. Often they're born with deformed spines, deformed legs, and things like that. Much the same as what the kind of symptoms that one would see from someone suffering from cerebral palsy. We find the same symptoms that we see in humans, we see also in the animals in that particular area as well. And we find this to be very concerning. But what is more concerning is that despite the fact that we have extensively covered this in the media, in the newspapers, on television, on radio, in the international media, and at conferences and so on, there seems to be very little interest in addressing these issues. And the communities that are living in the shadow of these mine dumps, and other studies have shown how, as Soweto expanded, housing came ever closer and closer to the mine dumps, and there are no exclusion zones around these mine dumps. But in any case, the wind doesn't respect an exclusion zone. You know, one particle of dust can fly at 10 kilometers an hour wind. It can fly for 1,000 kilometers, you know. So even if you do have exclusion zones, if the tailings themselves are not properly maintained, the impact on the nearby communities does remain a really serious problem. Which brings me to Zambia, where I work, where I did work in Solwezi, where First Quantum Mine has an operation. And there I found that the mining company actually had a trailer-driven electronic dust monitoring equipment in the surrounding villages. It had radon meters in the surrounding villages. It has very sophisticated dust monitoring systems there. It's a Canadian company that is operating their First Quantum Minerals. And I'm wondering why it is that in South African communities, we don't see the same level of sophisticated dust monitoring as what we see up in Zambia. And what what would be the difference? Is it perhaps because it's a global Canadian company that is up there, and our companies in South Africa seem to have gotten used to a regime which is not really very regulatory in terms of the activities of mining operations and mining companies in our communities. Because it would seem as if if you reside in a community that is able to make a lot of noise, able to get into the media, able to state your case and so on, you will be listened to. In the townships, the method of attracting the attention of the authorities is to burn tires and throw stones and so on, and eventually to get the police and rubber bullets being fired at you and so on, but still very little being done. And we really do feel that the issue of tailings dust in our communities can be dealt with if the government changes its attitude towards these problems and don't see these problems as policing problems rather than as actual regulatory problems, and holding corporations and so on accountable. The fact that we've got so many thousands of mining operations in our country that are abandoned is absolutely shocking. The fact of the matter is that it would seem as if it's the norm to abandon mines rather than to actually close them down properly and rehabilitate the environment. But again, if we look at the regulatory environment in Australia, for example, there a mining company remains responsible for the operation for 100 years after closure. And they talk about not just closure, they talk about completion. In South Africa, with our 2,000 abandoned mines, and we still see mines being abandoned. Mintails was recently abandoned on the West Rand. Central Rand Gold was recently abandoned just north of River Lee. There was a company that was recently abandoned in the Richards Bay area and so on. It would seem as if, because the regulator is not effectively regulating the law, we've got good laws and so on in terms of the MPRDA, mining companies feel that they can just walk away. We also feel that there's a gap in the legislation, and that gap in the legislation relates to major mining companies being able to sell operations that are no longer profitable to smaller companies which do not have the capacity to actually close these mines properly. And as in the case of Rustenburg Platinum, about 2 years ago, we saw that in the contract. What happened there was that the mine closure fund was actually discounted from the price that the mine was sold from one mining company to another mining company. So the new mining company actually has to start with its mine closure fund afresh, because that was part of the discounted price of buying that particular mining operation. And of course, ever smaller operators buy these mines, and eventually these mines end up being abandoned because these smaller and smaller operators cannot actually manage them. And then, of course, the operations get taken over by artisanal and small-scale survival miners, and no one looks after the tailings, and the tailings simply deteriorate very badly, and eventually just gets blowing, get blown in the wind. And if you look at the Vlakfontein 325 dump outside Snake Park, it is gradually walking towards the community. It's literally being blown by the wind closer and closer. And of course, every year with the rain season as well, it breaks down even further. And because it's on a downhill slope into Soweto, eventually it will be inside Tulani and Snake Park, as it is already. We can see the yellow streams of dust that the rain brought down with every rain season, and of course the dust in people's houses and so on, and the very high prevalence of children with birth deformities and so on. So we are very concerned as the Benchmarks Foundation that there should be corporate responsibility, that investment should be ethical, that the government should regulate, and that we should actually try and operate with the best global standards and not try and cut corners and so on with regard to legislation because we are driven by profit and greed. We should actually be driven by our concerns for communities and the needs of the country. We can't complain about crime of the poor and the indigent if we commit crime at the level of corporations and industry. You know, we really, if we want to deal with the issues that are confronting our society, we need to deal with them at all levels, and that includes the corporate level. I thank you.
Thank you very much, David. Yeah, it's very concerning to see the lack of response you know, to these reports and to NGO research. So continuing with the civil society perspective, our next speaker is Ms. Marietta Liffrink. Marietta is CEO of the Federation for a Sustainable Environment and the main character in the acclaimed documentary film Josie Gold. So Marietta is very well known and highly respected as an environmental activist within the Witwatersrand Goldfield region and has been the recipient of multiple environmental awards. So this afternoon, she's going to be providing an overview of documented data and information pertaining to the environmental risks and hazards associated with dust fallout within the Witwatersrand goldfields. And Cledwin, I'm not sure if you can share. Marietta has a presentation. If you can share on her behalf, that's great. Thank you. Thank you, Marietta.
Thank you very much, and thank you for the invitation. I shall be presenting on behalf of the Federation for a Sustainable Environment on the environmental risks and hazards pertaining to dust fallout within the Witwatersrand goldfields, the findings of peer-reviewed academic reports and governmental reports. This is, of course, a civil society's perspective. There is some duplication in the findings of these reports. The objective is to illustrate that there are anomalous findings in a wide spectrum of reports. I shall be borrowing from these reports, and I trust it will be with hyper-scrupulous attention to context and content. Can I please have the next slide? The next slide is taken from a 2008 report, an academic report, in which it was found that the Witwatersrand had been mined for more than a century. It's the world's largest gold and uranium mining basin, with the extraction from more than 120 mines of 43,500 tons of gold, 73,000 tons of uranium between 1953 and 1995, which led to a legacy of 400 square kilometers of mine tailings dams. That includes the 270 tailing storage facilities, as well as 380 mine residue areas, 6 billion tons of iron pyrite tailing, containing 600,000 tons of uranium. Uranium is low in radioactivity because of its extremely long half-life, 4.5 billion years approximately, and our gold ore in the Witwatersrand co-occurs with uranium. The next slide. The next slide is, contains some information from 2008 academic reports. It was found by Dr. Nkutsia of the Council of Geoscience that as a consequence of the uraniferous nature of the ore, the Witwatersrand tailings and other mine residues often contain significantly elevated concentrations of uranium and its daughter radionuclides. I here refer to radon-222 or radium-226, with the decay series of uranium-238 being dominant. Uranium-238, the 238 isotope, is the most common isotope of uranium found in nature, and unlike uranium-235, it is non-fissile. The next bullet point also again refers to the fact that the Witwatersrand contains appreciable concentrations of uranium and its radioactive progeny. Mining has resulted in the dispersal of radioactive material into the environment, and here is the focus of our discussion via wind-blown dust and of course other aspects as well. The last bullet point is taken from a report from one of the panelists, Professor Anagan, in 2015, where it stated that the analysis of recent monitoring campaign data has confirmed multiple occurrences of quartz-rich inhalable dust in residential settings at levels that exceed occupational health standards. Can we please have the next slide? This is again a duplication of what was found in a 2008 report. This is an academic report from Michael Sutton of 2007, where again it stated that the pollution related to Witwatersrand mines pose a number of hazards to surrounding communities. The major primary pathway is, inter alia, the airborne pathway, where radon gas and wind-blown dust disperse outwards from mine sites. The last bullet point, by living in settlements directly adjacent to mines, or in some cases living in settlements on the contaminated footprints of abandoned mines. We will go to the next slide, where there is again reference to a 2008 academic report, where again it is emphasized that the major airborne risk will be due to airborne radon and wind-blown dust. There is, of course, and these are all quotations from the 2008 report, there is little publicly available data on either of these contaminated pathways for the Witwatersrand gold mines. However, it could be expected that the most hazardous areas will be in close proximity to mine residue deposits or other large concentrations of radioactive material. In any pollution scenario, it is important to understand the risk posed by the pollution to the local population. Direct access to mine sites may also expose the public to risks due to direct external gamma radiation. Uranium has 3 rays, beta, alpha, and gamma radiation, rays, inhalation, and ingestion of radionuclides and chemotoxic metals. I hope I am still audible.
Absolutely, Mariette, carry on.
Thank you. Then to limit the risk due to external gamma radiation, the Chamber of Mines, now the Industrial Council, uses a guideline that each tailing deposit should have a 500-meter buffer zone surrounding it where no human settlement is allowed. In many cases, however, this guideline has not always been adhered to in the development of new settlements, both formal and informal settlements. The mine health and safety regulations, however, refer to a 100-meter buffer zone. The next slide. With the curtailing of gold mining on the Witwatersrand mining land is currently being developed. However, inappropriate developments such as houses or farms on mine residue deposits or the footprints or other contaminated sites could result in liabilities for the state, the public, and the closing mines. Avoiding built developments altogether and vegetating mine residue deposits and footprints with unsuitable plant species, such as those for pastures and playing fields, such as soccer fields, can also increase risks through the creation of attractive nuisances. These encourage use by potentially vulnerable receptors, such as grazing livestock and children. This is according to a 2007 academic report. The next slide is a case in point. This is where the Tudor Shaft informal settlement was established by the West Rand District Municipality in 1995 on a radioactive land. The principal radioactive pathway in this case is the ingestion of radioactive dust. It was also found by Professor Dorothy Tang in 2011 that it is estimated that 25% of the population in Johannesburg and Ekurhuleni live in informal settlements, and approximately 1/4 of them, or 400,000 people, are in the mining belt. The next slide, this is a GDART report from 2011. Thank you. That shows the areas in a red color where there are mine residue deposits or mine residue areas, and these had been classified as radioactive mine residue areas. This is a 2011 report. The majority of mine residue areas, according to the report, is radioactive because the Witwatersrand gold-bearing ores contain almost 10 times the amount of uranium than gold. We can go to the next slide, please. Again, the GDART report indicated that radioactive dust, that is dust pollution from mine residue areas, is one of the main issues relating to mine residue areas located in Gauteng. The next slide is just a photo of what it looks like during wind events within the West Rand. I may just mention that often with the dust monitoring, when it is monitored, it's done on a monthly basis. So obviously some of these significant dust fallout data is then being averaged out. The next slide we can go to, which also indicates that there are other sources that can be impacted. According to Professor Winder's report of 2004, stormwater drainage systems into which wind-blown dust from adjacent slime dams is flushed by runoff from sealed surfaces are also likely to constitute a major source of potential water pollution. And based on conservative assumptions, approximately 10 tons of particle-bound uranium per year are flushed by stormwater into receiving watercourses. We must also here perhaps just interpose that uranium's main health concern, it's not its radioactivity, but its chemical toxicity. So dust concentrations of up to 3,700 milligrams per cubic meter, according to Professor Winder, were reported from areas adjacent to Slimes Dam on the East Rand during a windy day. Now we come to the National Nuclear Regulators report. That is the next slide, please. The National Nuclear Regulator is the organ of state in terms of the National Nuclear Regulators Act of 1999 to protect the public property and the environment against nuclear damage. According to a 2007 report, it was mentioned that significant radiation exposure can occur in the surroundings of mining legacies due to the inhalation of radon-222 daughter nuclides from radon emissions of desiccated water storage dams and slime dams, the inhalation of contaminated dust created by wind erosion from these objects. Many of the dumps have no erosion control. The contamination of agricultural crop, that is pasture and vegetables, by the deposition of radioactive dust particles, which can cause considerable dose contributions via ingestion. Then I just want to go to the second last bullet point. It also states that it can be transported over relatively long distances because of the fine particulate matter of the dust, and it can be transported to agricultural used land in the surroundings. We can now go to the next slide, please. Now, how dangerous is uranium to human health? As I've mentioned, uranium is low in radioactivity, although if it is ingested or inhaled, the alpha emitters, that is the fourth bullet point, once deposited inside the body, can irreparably damage adjacent tissue and result in mutagenetic defects and other malign transformations. According to Professor Brugge, in the new findings, in the light of the new findings, that is the second last bullet point, apart from kidneys, uranium attacks the brain, acts as an endocrine disrupting compound by mimicking estrogen with possible consequences for the fetal development, compromises the immune system and damages the DNA. I will now go to the next slide, please. It again emphasizes if, for example, uranium particles are inhaled, the first bullet point, small particles are carried by the inhaled airstream all the way into the alveoli. Here the particles can remain for periods from weeks up to years, depending on their solubility. The last bullet point, insoluble particles may reside in the lungs for years, causing chronic radiotoxicity to be expressed in the alveoli. We now go to the next slide, where again reference is made to the National Nuclear Regulator. There are some of the questions which the Federation for a Sustainable Environment has asked in terms of the provisions of the Promotion of Access to Information Act to the National Nuclear Regulator. The response was that there had been delays because of COVID, but please notice that some of these reports date back to 2007 and 2006. So it is our respectful and considered opinion that the delays as a result of COVID is not applicable, and there is also no funds available for rehabilitation. That is that very last statement where it stated plans without funds are not implementable. So this is of significant concern to us. Here I also just want to interpose that there have been no epidemiological studies conducted in order to determine the causal link between anecdotal evidence and also tailing storage facilities and dust fallout. However, my organization, the FSE, had been contracted by the International Agency of Research on Cancer. It's an arm of the World Health Organization to collect 1,600 samples of human hair to test for uranium. The testing was done within the West Rand area. Regrettably, there was no conclusive outcome to these studies. It was non-conclusive. But I just now wish to refer to perhaps a solution. The last slide refers to what is currently taking place, namely the reprocessing of existing tailing storage facilities and the deposition of the tailings on a regional tailing storage facility. If these are done responsibly, if there are mitigation and amelioration measures put in place, as well as management measures, then it will remove the tailing storage facilities from areas adjacent to communities. However, as was mentioned by the previous presenter, and here I refer to the very last bullet point, closure planning runaway is limited because if that happens, then it happens. It happened to Mintails, who was liquidated with an unfunded environmental liability of 460 million rand. The impacts are now being carried by a mute environment, future generations, the state, and financially beleaguered municipalities. So I will end there. And perhaps if there is more time during the question and answer discussion, I would also like perhaps to talk more about Mintails because we're in litigation at present. Thank you very much.
Thank you very much, Mariette, for that really informative sort of overview of publicly available data and information. You know, giving us an overview of what is known, but also what is not known, where the gaps are. Our third panelist this morning, or this afternoon, sorry, is Professor May Hermanus. May is an adjunct professor at both the Universities of Witwatersrand and Cape Town and chair of the Chiamiso Trust. She has held a number of prominent leadership positions within industry, government, academia, and civil society, and has specific expertise in occupational health, safety, and sustainability in the context of mining in South Africa. May will be speaking to us this afternoon on good governance and safety of mine tailings in South Africa. May, I hand the floor over to you.
Thank you very much, Jenny. And I'm very happy to be in this forum. And I suppose if I think back on my involvement in the mining sector, today the focus really is on the issue of regulation and some of the problems that arise out of our regulatory environment that have left us with what is certainly a wicked problem of an enormous extent that has very, very serious implications for many people's health and their safety. So my intention is just to try and sketch out more from a regulatory perspective how we find ourselves in this situation and start to perhaps think about what the way forward might be. And of course, given all the work that has taken place in this area, it's already very clear that the solutions aren't immediate and none of them are easy. This is a complex problem with a very long history that's tied up not only with mining, but also with the apartheid system. So let me just start off by saying, if one looks at mine tailings or looks at the terminology around mine tailings, there's many terms that are used, like mine residue deposits, tailings dams, dumps, heaps, piles, etc. And you know, there could be terms such as residue deposit, reserves, and so on. Essentially what they are is a separation between the categories of, are mine tailings a resource? Are they a waste product? Are they a byproduct? And the way that they are captured in various codes in our regulation has important effects. Now, the most critical one is that, or the two effects are that if something is classified as a waste product, obviously it has to be treated as waste, and all of the implications around NEMA may come into effect. Now, I'm using the word may because I want to come back to that. The other aspect is the often conscious decision not to classify tailings dams as waste, but as a resource or as a reserve, in the hope that new technologies will develop, which can lead to the reworking of these mine residue deposits, as we've already seen, and with many outcomes that have not been satisfactory. If one just looks at the legislation, however, there are 7 acts that essentially deal with issues related to mine residue deposits, obviously starting with the Constitution, through the MPDRA, the Mine Health and Safety Act, which were amongst some of the earliest legislation, and the various acts that are associated with the Department of Environment. Now, the key issue here is that all of these arise very long after mining has started, and as I think most people on this within this conference would know, that it's not possible to apply legislation retrospectively. So we have a problem that's historic and that is not subject easily to current regulations. What is that then? And if one just looks at the timelines involved, so we're talking about legislation that comes into play from the mid-1990s onwards, when we've had our earliest mines starting in 1867 in the diamond fields, our earliest coal mines starting in 1870 in the coal mines, and the gold mines starting in 1884. The coal mines become important, the formation of, or the promulgation of all this legislation and codes. So what does that mean then for the process going forward? Actually, before I go there, I just want to point out, I think a key issue, which is that the documents that are still very fundamental to the construction of tailings dams is the SANS document, the South African Bureau of Standards document 10286. And that document is really around the structural integrity and stability of these tailings dams. So that document, which has been fundamental for the last 100 years and over that, it doesn't deal with environmental and occupational health and safety issues. And it's only these latter acts that do, as well as obviously the new global industry standard on tailings that was considered or introduced by the ICMM last year, which certainly covers only a small fraction of mines. Now, if we look at the Mine Health and Safety Code of Practice on 2001, one will see a typical life cycle approach, which goes to right through from construction monitoring right through to decommissioning, as well as long-term monitoring for stability and safety. Again, obviously, the problem here that this is not something that can be applied easily retrospectively. That code also represents all of the hazards and the impact of these hazards on people in respect of radiation-related matters, issues related to water, issues related to the chemical characteristics of these tailings. That, I think, leaves us then with the conundrum: how do we find our way out of this complex and difficult situation? And these are just some thoughts that struck me in preparing for this conference. The first is that it would help us if we started to identify the operations that are historic and where we're needing to find a collective solution from many quarters, and those which are in fact subject to the law that is currently in place. And the focus there would be to ensure that there's adherence to the law, but also to see whether there's adequacy in the legislation. And I suppose that in my heart of hearts, I wonder whether our regulatory regime as it stands, given unresolved. But if one looks at what we are dealing with historically, we clearly need to come together to understand, to agree on the size of this problem and what can be done over what time frames, and also look at the issues that are immediate that could lend themselves to interventions that are more short term. But my sense when I listen to the speakers that have spoken earlier is that clearly the impacts and the implications or health implications and safety implications of these tailing dams are well understood. So we need to find a systematic framework on how we move forward, and that has to have aspects that relate to both the geometallurgy of these tailings dams, the environmental and health consequences, as well as some of the economic aspects that are associated with them. So, some of the work, I think, Jenny, you yourself have been involved in, and there's more work that's being done on how mine waste could be repurposed. How does it get, can we characterize it? Can we look at repurposing at the same time as cleanup? And some of the repurposing issues that or opportunities that have been identified are the making of bricks, the use in ceramics, the use in cements, the use as backfill in mines that need backfill, although that's a very limited use, the use in construction materials and road building materials. Now that obviously means that all of these waste in some way would have to be decontaminated from their harmful constituents. We also see that, and I'm interested in the work that is going on in Sibanye Gold, and I'm not familiar with that work, where there is a consideration of how one retreats these tailings dams, and I guess that retreatment approach really warrants some close evaluation and some close attention to check how effective it is. I think what also concerns me is that we continue to mine at scale. The gold mines are obviously the biggest contributor to the problem of mine tailings, and the gold mining industry is at the point where it is in decline and resources are very scarce. So there's some real pressing interventions that are required there. But we also have very much larger, large open cast mines across the country where equipment of significant size is being used, and the potential outcome for the creation of yet another significant set of tailings related problems is certainly on the horizon. So there's a need to understand and to map adequately amongst all of the parties involved, both the consequences of the past, the consequences of the new, and the consequences that are associated with the trajectory of mining. And that's a fundamental conversation, given that mining is still, and I've just come out of part of a conference on the mining sector, where it's still a sector that is seen as a growth sector for jobs in particular, and that will drive the delivery of energy to the country. So there are quite a lot of expectations that are not easily aligned, that need to be confronted, and we need to work towards some sort of alignment that makes sense for the country in the long term. I'll leave it there. Thank you.
Thank you, May, for highlighting the complexities involved. And as you mentioned, I'm one of those people that's all for removing risk at source. Get rid of tailings dams. That's something that I really would like to see happening as a standard practice in my lifetime. But I'm very also aware that tends to be a sort of simplistic engineering type of solution, and there's a lot more complexity involved. So thank you for highlighting some of those complexities. Okay, so shifting to now really to more on the actual health related issues. Our next panelist is Dr. Charlene Andros. Charlene is a medical scientist with the toxicology and biochemistry section at the National Institute of Environmental Health, and she has expertise in particle and nanotoxicology. So Charlene has undertaken extensive work on the health impacts associated with dust emissions from gold mine tailings, and will be providing us with an overview of the findings emanating from this work this afternoon. So Charlene, I hope that you are able to share your screen. I am aware that you've got a presentation if you wish to, and I will hand over to you. Thank you.
Okay, so I am trying to share my screen. Let's see if this works.
Yes, let's see if it works. If it doesn't, then we can help you from our side. Something is happening, Charlene. In a few minutes, it says Charlene has started screen sharing.
Okay.
If it'll pop up, I'll let you know as soon as it does.
It says to double click to enter your full screen mode, so just try that.
There we go.
Is it working?
Yes, it's working.
Okay, and tell me, do you hear me properly?
We hear you well.
Okay, great, perfect.
Okay, thank you.
Okay, so thank you for that introduction. And some of the work that I will be discussing today formed part of my thesis. And that was submitted in 2019. And then also this work was funded by the Mine Health and Safety Council. And I really also have to give credit to Prof. Harold Onegon, who was working at UJ at the time of this study, and then also Prof. Kuku Vui, as they formed part of our collaborators on this big mine health and safety project. Okay, so now the NIOH group has also published 3 articles that are available online, so I would definitely recommend going through these articles for a more detailed explanation of the work that I will be presenting today. Okay, so now we focused on 6 tailing sites. The one was the DRD site, PM tailing site, which is located in Boksburg, and then also the Ergo site south of Brakpan, sorry. And then we also looked at sites 5 and 6, and these were located in the Klerksdorp Stilfontein area. And the period of this project was from about 2010 to about 2016. So just to give you an idea of when the results were published and made available to the public. Okay, so now this is just a very simplified snapshot of the overall study design. And first we collected bulk dust from all these tailing sites. We then recorded continuous real-time ambient dust levels from surrounding residential areas. Thirdly, we collected PM10 filter samples, also from the surrounding residential areas. And then lastly, we collected respirable personal filters from surrounding schools. Okay, so I will discuss the main results from each of these sections in the remaining presentation. So now for the bulk dust. So now the bulk dust was collected and sieved, and these samples were found to contain very small particles able to reach the deeper areas of the lungs once inhaled. So these particles can easily settle in the thoracic as well as the alveolar sections of the lungs. And then also, yeah, that is what I've mentioned just here. And then also several minerals, of course, were identified, including crystalline silica polymorphs, of which quartz was the most abundant. And I won't go into too much detail, but this section formed a major part of my PhD study, in which I looked at the in vitro toxicity of these dusts in human lung cell lines. I looked at bronchial cell lines and I looked at alveolar cell lines as well. So if you treat the cell lines with these dust particles, you do see quite a decrease in viability, meaning that the dust particles are obviously toxic. Okay, so now I've also included this slide. It looks a bit, a lot of information on the slide, but what I want to share with you is just to show you that the surface elemental composition, with regards to that, the particles showed iron concentrations. And then also when looking at the elemental composition, of course, the dust contained gold, it contained arsenic, it contained iron again. It contained all the major metals that you would assume would be in these particles. Okay, so now moving on to the continuous real-time ambient dust levels that we recorded at these surrounding residential areas. Okay, so now let me just move on to this. Okay, so in the interest of time, obviously, I will only show the results of one tailing site. So this is the tailing site in the Soweto area. And the idea behind this was to see whether dust levels higher than the 24-hour national ambient PM10 standard of 75 microgram per cubic meter would be exceeded. And if you look at this figure below, or in this slide, within a time period of 1 month, this standard was exceeded up to 4 times. And this was in the month of October. So this is clear by looking at the gray line, and then obviously the red line just shows the wind speed that was recorded within this period. So clearly the standard is being exceeded. Okay, so obviously I have results of this, of all the other mine tailing sites, but of course, as I've mentioned, in the interest of time, I would just show this. And then moving on to the actual PM10 filter collection at these surrounding areas. So now these results just basically corroborate what I've shown you just now in the previous slide. And that is that the dust levels, including obviously the silica levels, was quite high. And if you look at this figure here, high ambient crystalline silica levels was recorded, and these reached levels as high as 90 and 75 micrograms per cubic meter. So this is silica only, it is not the dust, but it is the silica contained within the dust collected on these filters. So now South Africa has not yet set an interim limit for non-occupational crystalline silica. So therefore, international limits were looked at. And then obviously, most of the samples that we collected exceeded the levels from the Agency of Natural Resources, and then also from the US EPA. Okay, so then lastly, we looked at, let me just move on here so that I do not miss anything. Okay, so now several schools surrounding these tailing sites were identified, and scholars between the ages of 12 and 14 were selected, and they were given Gillian or Gillian air samplers to carry throughout their school day. Okay, so now for each school, and the average respirable dust levels and wind parameters on the day of sampling were recorded, and an assessment was made as to whether schools closer to the mine dumps experienced higher dust levels compared to schools further away. So then again, I'm just showing the results of one tailing site, and this is again the site at Soweto. And then as you can see here, the PM4 levels reached 120 microgram per cubic meter, and this was for a school 1.83 kilometers away from the tailings. So now when you look at schools further away, so this school in particular is 5 kilometers away, and then another one is 2.25 kilometers away. These schools showed a lower dust level compared to the one closer to the tailing site. Although what I do have to mention here is that with the wind parameters collected during each of these school days, it could clearly tell us whether the tailings could have contributed to the dust levels. So if you look at this wind rose, you can see that dust came from the northeasterly direction, which shows that it did not come directly from the tailing site. So basically what we did is we got these wind roses for each of the sampling days, and we did this for each of the tailing sites. So we can clearly see whether the tailings contributed to the dust levels on that particular day. This was quite interesting. The only thing that I do have to mention is that these schools were sampled on only one day. It was impossible for us to get an average of a month or a week at each school. We didn't have enough time or resources to do that. So that I must say was one of the limitations of the study, is looking at just one sampling day. Okay, so now moving on to the adverse health effects. So now our colleagues at Pretoria, University of Pretoria, so that's Vuzumuzi Nkosi and Prof. Kukuvui, they focused quite a lot on the actual adverse health effects of communities surrounding these mine tailing sites, and they have published their results as well, in case anyone is interested in reading that. Now, they specifically looked at the elderly population, and as you can see with the first figure in the slide, they looked at the prevalence of asthma, chronic bronchitis, chronic cough, emphysema, pneumonia, and wheeze. And just clearly when the exposed groups, so this is now the groups closer to the mine tailings versus the unexposed, so this is now the populations further away, 5 kilometers and more from the tailing sites, you can clearly see that there is a higher prevalence of these diseases in the exposed groups. So they also did the multivariate regression analysis, and that also showed significant association of these diseases in the populations closer to the mine tailing sites. So this is now for the elderly, and then they also did the exact same study for adolescents, again comparing the exposed group versus the unexposed group. And in this population, they could see an association or a significant association of the exposed group living near the mine tailing sites and current wheeze, as well as with rhinoconjunctivitis. So clearly, our scientific study shows, yes, there is an association between adverse health effects and living near these mine tailing sites. Now, it does feel to me as if this study was basically just adding to the pool of information that was out there, and I really enjoyed the previous presenter's talk where she said, yes, this is all this information is available. We can add to this information, but the problem is that action needs to be taken. That is basically the whole point here. We could do another study and it would basically show the same results, but what is the action? What is going to happen? What's the next step in terms of legislation? Okay, so that is the end of my presentation, and yes, I would gladly answer any questions after all these presentations are done. Thank you very much.
Thank you. As you say, it certainly does show that it backs up what the previous speaker has said, May said, is that, you know, there really does seem to be an understanding that there are impacts. So, you know, why, it begs the question, why is nothing being done about it? We can maybe discuss that later. But staying with health, our next speaker is Professor Jill Nelson. Jill is an occupational health epidemiologist and the head of the Occupational Health Division at the University of Witwatersrand School of Public Health, and her expertise lies in the area of exposure hazards and diseases in the mining industry, including asbestos and silica. So Jill will be giving us a research perspective on both the challenges and approaches in assessing health risks associated with environmental emissions. Jill, would you like to share your screen, or alternatively we can do it for you?
Thanks, Jennifer. Nice to see you all here. I know some of you, others are new to me, but yeah, collaborations and networking is fantastic. Okay, so let me share my screen. I do have a PowerPoint presentation here, which I'm going to, if I can get it to work, start doing that.
Okay, yes.
Now.
Showing, you can just put it in slideshow mode. There we go. Okay.
All right. So, as you said, Jennifer, I'm going to be talking about challenges and approaches from a research perspective, because that's what I do. My experiences in research. I am not as clever as some of these other people who do all the spatial modeling and assessments, but I'm going to talk from the other side, from the outcome as opposed to the exposure side, with a little bit of exposure. So we know that there are various routes of exposure for things like uranium and the other metals, etc., that have been mentioned in previous talks. They can be inhaled, they can be ingested, they can be consumed through eating soil, either through geophagy, which is sometimes happens during pregnancy, where women have this urge to eat soil, which they do, and then of course children also pick up, you know, end up with soil in their mouths just when they're playing, and of course there's also dermal exposure. So I want to move on to the health effects, and really one of the big things that has been mentioned is uranium and radon, etc., which is obviously a big problem, and it's found in both water and in the air. So one has to think of those different routes of exposure that I presented on the previous slide. And uranium and radon and the decay products have been associated with leukemia, bone cancers, effects on kidneys, as some people have mentioned, endocrine disruptors also been mentioned that can produce, apart from birth defects, can also produce or cause reproductive cancers. And then we've got the other, you know, the bone sarcomas, etc. And of course, not only uranium, but some of the other metals that Charlene just mentioned, like lead and arsenic and nickel, etc. So what are the problems, and why is it difficult to research these health effects? And it is very difficult to research them. So first of all, risk assessment in itself is a difficult thing to do. It's not easy. Anybody who's tried to do it, anybody who has done it will back me up here that this is not a simple process. It's difficult to trace sources. And I'm talking generally. Obviously, with the mine dumps, we know where things come from, so we know the source of that. But in terms of I'm talking generally, environmentally, you know, other places, other other sources of exposure, etc. One doesn't always know exactly where they're coming from. We have to look at spatial and temporal patterns. We can't just take a single shot in time, which I'm going to come to in a moment, but we really have to look at what is happening both spatially and temporally in time. And what are the pathways of exposure? There are certain methodological issues. We have to, well, in an ideal situation, if we want to really look at health effects from exposure, we use biological monitoring, biological sampling, yeah, from things like blood, urine, hair, as we mentioned, nails and teeth, and bone. And this is great in an ideal world, but if you're going into a community, people often don't want their blood taken. Urine is usually not a problem. Hair and nails can be a problem. There are cultural beliefs that one has to take into account. The technical issues in actually measuring the, say, for example, the heavy metals in one of these, one of these, you know, hair, urine, etc. So just to give a little bit of an explanation of why I'm talking about this specifically is I am moving, well, I have in the last 10 years, actually, I've been doing research on the environmental effects of, well, the neurological effects of environmental exposure to manganese. And we are in the study using hair and nails, and we have definitely come across problems with study participants actually being willing to have samples of the hair and nails taken. I mentioned teeth and bone here, which are obviously a little bit more difficult to take from participants, but we have a study actually in deceased manganese miners, and at autopsy, we take a piece of bone and a tooth and look for manganese in those samples as well. Then what needs to happen is, you know, a lot of this risk assessment, a lot of the exposure assessment is done through modeling, and which is great, and they're very sophisticated techniques that are used, but really what we need is individual exposure assessments. And Charlene mentioned going into the schools and taking some personal samples, which is great, but also I'm going to move on to the problems in that kind of design in a moment. When one is doing health effects research, it's essential to get buy-in from the community. And yes, in Snake Park, for example, there's obviously huge buy-in. The community is very concerned about what is going on there, and they, I would imagine, would be very happy to have some research conducted. But the research needs to be collaborative. It can't be done by one group. The communities have to be involved, as I mentioned, but we also have to have government involved and research organizations like the universities, the National Institute for Occupational Health, and others. And it's essential that some people, the people who are running the study, doing the research, are familiar with the community, so they understand what happens within the community. You can't just come in, with a helicopter approach and try and do research in a community. It doesn't work. So I want to move on to long-term health effects, because there has been mention of the short-term health effects, but the long-term health effects are far more difficult to measure and to understand. And obviously one of the main long-term health effects is cancer, which is a concern. Uranium especially has been, as I mentioned, and you all know, is associated with exposure to, well, sorry, it's associated with various cancers, including bone cancer. And most of the studies that are done are cross-sectional studies, which means that they are done at one point in time. So I think all the studies that have been mentioned, apart from the Rivoli study, which I know is a longitudinal study, are done at a single point in time, which means that you can't actually determine whether there's causality. You can only determine association. So you don't know which came first, did the exposure or the cancer or any other long-term effect come first? Did the exposure precede the effect, the health effect that you're looking at? It's very difficult. It's impossible to tell with a cross-sectional study. So one has to use case control or cohort study designs. A case control study is where you would identify all the cases of cancer, and then you would look for controls. A cohort study design is longitudinal, where you follow up people along over several years. But there's certain challenges that are related to that. In this country specifically, there's an underestimation of cases. They're difficult to find. There's an underdiagnosis of cancer, especially in areas like Snake Park and other informal settlements that are around the mine dumps. Cancers present at a late stage, which means very difficult to follow them up. People unfortunately pass away quite quickly. Cancer prognosis is poor. It's difficult to find controls, very, very difficult to find appropriate controls in a case control study. And if you are looking at a longitudinal study, people move around a lot. So there's a loss to follow up, a major loss to follow up. And we found this in our one of our studies on manganese, where even going back to people a year later, it was very difficult to find many of them because they move out of the community. And that completely undermines the validity of the research that one is doing. You have to think about effect modifiers such as smoking. I mentioned lung cancer earlier, but you have to know whether the individuals are smokers or ex-smokers. Need to look at things like HIV. There are also confounders like age and sex, so one can't take a community just in its entirety and lump everybody together. You have to stratify by age and sex. And then there's this thing, information bias, because you ask people questionnaires and it's human nature to sometimes respond in a way that you think the person wants you to respond. Also, people forget what they might have been exposed to or when they were exposed. So you've got recall bias. So there's a lot of potential bias that occurs in these longer term studies. And then in South Africa, we have incomplete population registers, very difficult to get denominators of people. We have incomplete disease registers. And then we need to have quality control and oversight. I mentioned that people who are familiar with the community need to be overseeing the study. And in these long-term studies and these sophisticated study designs, you really need to keep strict control over what's going on. And then of course, there's the cost. These studies are very expensive, especially the longer term studies, both for measuring the exposure and for diagnosing disease. So I mentioned it's difficult to trace sources. I think this, I'm going to move on from the slide and just go onto this quickly. I mentioned that we need to measure exposures in individuals, but it's there's this concept of the internal exposome, which is about looking at exposure or identifying exposure through a person's lifetime, including in utero, which is obviously very, very difficult. But because these cross-sectional studies often, well, because they always look at a point in time, they often don't take into account occupational histories, where people have worked, what they might have been exposed to in their jobs, and where they might have lived previously. And then one needs to look at what exposures might have been in the areas in which they previously lived. So these are very complex studies. One also has to look at omics. This is a relatively new, well, they are relatively new technique, and really looking at the interaction of genetic and environmental factors that might initiate pathogenesis. And this is at the molecular level. So we look at genomics, epigenomics, proteomics, cytomics, metabolomics, etc. And the recommendation now is actually not to do these individually, but to actually look at them all together and see what is going on. So I know that I've mentioned, I'm just going to go to my last slide. This is a very nice diagram of all the omics that exist. So while I've spoken really about the challenges, I think within those challenges, there are approaches that one can adapt. I'm not going to summarize them because this presentation is quite short already. But these are the things that one needs to take into account when doing research for long-term health effects. And yeah, I'm happy to take questions. Thank you.
Thank you very much, Jill, for really highlighting, I think, some of the challenges in determining causality. You know, it's often said that we don't have enough defensible evidence, and I think both you and the previous speaker Charlene have really highlighted some of the challenges in getting this data. And I was very glad to see you emphasizing the need for interdisciplinary and multi-stakeholder collaboration around these issues. And you've also mentioned exposure, quite a lot during your talk, and that's where we're going to now switch to. So our next speaker is going to be Dr. Raisa Muller. Raisa is a senior lecturer with the School of Geography, Archaeology and Environmental Studies at the University of the Witwatersrand. And today she will be sharing with us the outcomes of her research on dust dispersion modeling from tailing storage facilities in the West Rand district. So Raisa, would you like to share your screen? I know that you've got a presentation as well.
Yes, Jennifer, could I ask if you could just share some
Edwin, have you got it loaded up? Would you like to share it? Or I can try and find it on my computer.
I'm just worried with the connection. I may.
That's fine. Yes.
No connection. Yeah. Thank you.
We did. I know that you sent it through. Edwin, have you got it there?
Yes, I've got it. Sorry, I was trying to unmute myself.
Okay, and share at the same time. I know the challenges. Okay, thanks.
So, afternoon, and thank you for this opportunity to present some of the work. This forms a lot larger a project that we've been working on for the past almost 3 years. It does involve one of my PhD students and another scientist also at the university. And this specific research that I'm going to share with you today is more on the modeling side. So it is the exposure measurements. We had done quite a few different monitoring campaigns as well, but this presentation more is aligned to the modeling exposure limits. Next slide, please. So not to repeat or go into the detail that everyone else has gone into, because it's just going to be a repetition then. But sorry, I just need to make the screen a bit bigger. So not to repeat what others have said, but it is quite important for us to look at these TSFs or the tailing storage facilities, especially when the windy season comes along. So this specific gold mining village that we were interested in is actually one that was liquidated. It was a liquidation that happened quite randomly. No one noticed anything coming of it. And so that was quite a big problem. So since 2013, when a nearby gold mining company was liquidated, this community has been complaining about dust fallout. They have stated that the houses were covered in dust. Many of the children had coughs when we visited the site. It was quite a problem. So we conducted an air quality assessment using dispersion modeling, specifically to look at the wind-blown dust in the area. Next slide, please. So I'm not too sure how clear the pictures are in terms of the wind, and you can actually see the dust in it, I hope. But on a windy day, and generally it was either around autumn going to winter or the spring season, you could actually see the dust in the air. You could notice it on tabletops, on the floor. You could feel it if you held your hand out for, but you could actually notice the dust. So it was quite a heavy dust, almost like a dust storm it would cause, and it was quite a problem. There are other community areas around as well, which I'll also show you on the next slide. And this is quite a problem for many of the areas. Next slide, please. So in terms of the study site, Clevin, if you could just click so that it highlights the gold mine village now. Just click next, it would highlight, as if you turn into the next slide. Yeah, so that's the gold mine village that we were specifically concentrating on. And again, if you just press next, you will see that there are the three main, Kutsong, Carltonville, and Videla. So Ledwin, if you could just press next again for me, just to highlight, yes, to highlight those three areas. Besides the actual gold mine village, these other three areas also had quite big residential area. There were smaller, more informal settlements as well around the study site. And one more time, slide one, please. So those are the specific, the yellow dotted areas are the specific sites where we did actual monitoring of the TSPs, of PMs, of silica, uranium, etc. So more or less, just to give you an indication, it's quite close to the Carltonville area where this was done. There's many TSFs, there's 7 in total. There's many other facilities around, but as was liquidated, nothing was rehabilitated as yet, even 7 years later. Next slide, please. So in terms of the methodology, and I'm not going to go into too much detail with this, just because I see that the time is a bit later, but we actually did many different methodological designs, and we used some surface fraction data, we used some PSD analysis, we did some emission estimations through modeling, dispersion modeling using AirMod. We did chemical analysis, which I'll go into a bit more detail in the next slide. And then many of the meteorological parameters as well were analyzed to see specifically the wind blown dust. So if somebody is upwind, downwind, on windy days, non-windy days, also to get an indication of these very specific wind blown dust and the dust fallout from there. Next slide, please. So in terms of the air quality, as I mentioned, we used a dispersion model to determine the wind-blown dust, and then the surface material from the TSFs were sampled. They were analyzed for silica and the heavy metal content. I'm not going to go into a lot of detail on that. They are in most of the publications, but we did use X-ray fluorescence and inductively coupled plasma mass spectrometry for the two, for silica and heavy metal content respectively. The results were very interesting in that, as everyone else has mentioned, we know these things are there, we know that it's coming out. We actually have data to show that they are high levels and people are being exposed to it, though there's very little legislation around it, specifically in South Africa. Next slide, please. So in terms of the particle size from the specific, the TSFs around the gold mine village, the TSF1, which is more to the north east, and Savuka 7, which is more south, are the biggest health threats, and these are owing to the high respirable fraction of the PMs. And also just around the gold mine village, because the TSF particle size distribution did show slightly smaller particle sizes as well as larger. The smaller the particle size, as most of you would be aware, is the ones that we're quite concerned about. But throughout the different TSFs, we actually found particles, various different particle sizes. So they could be anywhere from sinus effects to lodging in the alveoli, to affecting the lungs, and they could have both short-term acute effects as well as very long-term chronic effects based on what the source apportionment and the actual particle, the structure of the particle was. Next slide, please. So in terms of the TSPs from all the sites around, and this is more seasonal evaluation of it. So it was also, we needed to, besides just what is the particle size, what do these particles contain, what are the heavy metals, we wanted to see if there were specific increases or very high levels in specific months. And the highest emission rates were noted from winter to spring, while the mine was under the supervision of the liquidator, which is quite interesting because this was from 2012 to 2016, it was noted. And this is specifically for the TSPs, your total suspended particles. So even though we're considering the windy season around just August, we actually noted from July this increase in the TSP emission rates increasing. Next slide, please. And then when we're looking at the PM10 sites, the highest emission rates were reached during the winter season, which is June to October again. But it also continued for certain very specific TSFs. So it showed the least emission, the better vegetated TSF showed the least emission rates, which is quite good because this reinforces the premise that the rehabilitated TSFs are a lower environmental and human health threat. However, having said that, it does not mean that other components are not dangerous. So it's specifically related to the PM10 levels that we noted this, and for other ones as well. Slide, please.
Sorry, I'm in a conference.
And I'm also on.
So if we look at some of the results, and these are more the modeled one, the simulated highest daily one, the simulated from TSP, from PM10, etc. And what is noted is that we are actually receiving very high levels in very specific areas. So when they are modeled, it's not to say that it's specific to an area, but it was noted in the TSF6 and the TSF1 that we are getting this constant high levels, whether it's your PM10, your TSPs, or your particulates. So all of these do show very high levels, and this is where the problem comes in again, is that whether we monitored so in situ measurements or whether they were modeled, we did find areas that were more problematic than others based on the meteorological conditions of the areas. Next slide, please. And then just in terms of this silicone, or the silica exposure, and this actually again comes back to what most of the other speakers have been mentioning, is that when we look at silica, it is problematic because of the respiratory conditions and disorders that are associated, but there's no standard that exists for the public and only for occupational exposure. But we did find levels that were above the recommended, at least the US Environmental Health Hazard Assessment, which measures to about 3 micrograms per cubic meter. We were measuring much higher in the region of sometimes 7 to 8 micrograms per cubic meter, or even higher, depending on which month the simulated average was for. So the annual averages were slightly lower, but there were months that were extremely high, and this was problematic. So specifically, we noticed that the results exceeded for TSF1, TSF6, and the Sabuca. So both north, east, and southwest, more or less, in those areas, due mainly or predominantly due to the wind direction and wind upwind and downwind of the gold mine liquidation area. And then this or rather placed a threat to the community at Ward 5. However, it didn't reach as far as Ward 27, which was much further south. Much further north. And then the TSF6 and the Sabuca 7 had very high health effects when we did the health risk assessment. That was a simulated health risk assessment, as Joe pointed out, to do a full health risk assessment where actual monitoring of health effects are very difficult. So they were simulated through modeled results and calculations. But we did notice in the other studies that there were very high levels of problems, both respiratory and cancer risks associated with the silica and the uranium levels that we noted. Next slide, please. So just in summary, and it's a rather brief overview, but just to give you an indication, you can have a look at the further, it's quite a detailed study around the specific area in different journal papers, but just to give you an indication that the PM10, the dust fallout, it was high in silica and the uranium content, and it could potentially pose health threats to the surrounding community, which we did notice through the health risk assessments. Those simulated, we did notice these were extremely high in other results. And the dust deposition was the highest in July to October, with the TSF6 posing a nuisance, and while TSF1 represented a potential health threat owing to its particle size distribution, specifically for the Gold Mine Village community and Sebulka 7 as well. And potential receptors of the air pollution by dust were included in the study were neighboring property owners. There were some business owners of nearby shopping center, which complained continuously about the dust. They also, with COVID, it did help a bit because of masks, but they continuously complained that the shops were extremely dusty and they couldn't keep their doors closed because they were businesses. The school suffered quite a bit, and the nearby clinic also noticed an increase whenever there were high levels of dust or windstorms. So the sudden mine closure, the sudden mine closure due to mine liquidation did result in unrehabbed TSFs, and this did, in no uncircumstances, exacerbated the dust deposition in nearby areas. And it's something that isn't legislated very well. It isn't monitored very well. There's no one really responsible once there's a liquidation process underway. And we have noted that it was quite problematic. So this is just a brief overview, and I thank you.
Thank you very much, Lisa. Once again, I think, seeing evidence of the fact that there is actually exposure occurring. As May said, we know that these health risks do exist, and the evidence seems to really be backing up scientific evidence, backing up anecdotal evidence here. So staying with the theme of emission monitoring and measurement, our final panelist, and last but not least very much, is Professor Harold Anagon. Harold is an extraordinary professor with Northwest University. He has extensive expertise and experience on emissions and management of mine dust, both as an academic researcher and independent consultant to ERGO. And he's going to be sharing with us some of his expertise on monitoring and measuring of mine dust emissions, with specific emphasis on the wind-borne dust from gold. Thank you, Harold.
Thank you very much, Jenny. I have unmuted and turned on my camera, and I will now share my screen.
Thanks, Harold. I'll let you know when it comes through.
Okay, you should have my screen now.
Nothing showing yet. It's a little bit slow. Not showing that it's sharing. You want to double click there?
Okay, let's try again. Okay, here it comes.
Nothing coming through yet, Harold. There we go. Something's happening. There we go. I can see it. You can just put it in slideshow mode. There we go. Thank you.
Okay. Thank you very much for the opportunity. Having the last word is always an advantage. I will try and focus most of my remarks on them as requested on the monitoring and measurement of the mine dust emissions, although I will make some comments and responses to the earlier events, the earlier talks. Specifically, the Benchmark Foundation has put out a challenge as to why in South Africa we're not using a more sophisticated method of monitoring, such as he recorded being observed in Zambia with a very sophisticated multi-parameter measuring device on a mobile platform. I guess this type of slide that you see here has been shown several times before against a backdrop image of a satellite image that highlights in bright white the mine tailings deposits of the central Witwatersrand, where the central and east rand is more where my work is focused, but I think that the methods of monitoring apply equally well to West Rand. And as Raisa has just pointed out,
the area of Far West Rand, of Welkom and Coltonville is a vast area of unrehabilitated mine tailings, which is going to be the focus of all our attentions at some point in the future. Highlighted in red circles are 4 of what I term the mega dumps. These are the very large tailing deposits which have been the focus of a lot of the action and concerns as sources of dust over the year. We've heard several references. Snake Park is to the southwest corner of what I've termed the DRD dump. I'm using the colloquial terms. The central gold complex around the Soweto Highway, we'll come back to later. East Rand Premier Mines in Boksburg, and the Ergo operation in Springs. Okay, so let's just step back a moment and say, what exactly is the function of monitoring? Well, as those of us who are involved in the consulting business in one way or the other, the first issue of monitoring is to comply with the legal requirements. In other words, the companies would like not to get involved with legal cases or suits by not complying with regulations. So the first purpose of monitoring is to conduct monitoring and report results in compliance. But I've got a caveat on that. The next thing, and this is my strong assertion, is that the function of monitoring is to provide management information to the company that has commissioned the monitoring. So the criticism often put forward by NGOs, etc., can you trust monitoring results if they are paid for by the companies that are causing the pollution? Well, trust for what the companies themselves are paying for the monitoring in order to better manage their own operations. The first thing that they need to know is, are the mitigation measures for which they are paying, and this is non-revenue generating costs, so they obviously want to know it's cost effective. So are these measures in place and effective? If there are incidents of breakouts of dust or of physical collapse or water leakages or pipe bursts, monitoring of various sorts is necessary so that the company can get immediate warning that things are out of control and that appropriate remedial action is required. They also need to establish trends. Are the measures effective? Are they meeting the targets of continual improvement? And so on. And in the event of external complaints, whether from public complaints, compliance notices from government agencies, or in the worst case, legal action instituted by whatever parties, there needs to be science-based evidence to support or refute the claims that are made. So really this purpose of monitoring is that. And I would even go further and argue that the first item, compliance with legal requirements, is in fact also a management purpose. In this case, a management by the authorities who have a responsibility in terms of the constitutional rights and the Environmental Management Act, that air quality limits are being complied with. So they need information in order to manage that process and interact with the industries in the case that there are exceedances. You'll note that the air quality regulations or ambient pollution, including the dust regulations, do not include any penalties for exceedances. In other words, if the air quality is above the limit, there isn't a criminal that you can directly prosecute, as in the case if you've got emissions from a stack. If you exceed your stack emission limits, then you can prosecute the CEO of the company. But in terms of ambient, it isn't a crime, so it's a matter of managing the process. So the penalties in terms of the Act are for not having an air quality management plan in place and not submitting reports. So those are things that you can be prosecuted for in terms of the dust regulations. Okay, so what exactly do we mean by air quality monitoring? forgive me for being pedantic about this, but it is important in the context of contrasting monitoring versus these specialist health impact studies, which as previous speakers have addressed. So it's a routine, continuous measurement of an indicator property, whether it's concentration or deposition rate of an identified atmospheric contaminant. I want to emphasize this word indicator property, because we cannot measure in all places, at all times, at every sensitive receptor. We've got to choose representative sites and there. So the indicator properties of criteria widespread urban pollutants, for instance, the criteria pollutants for gases and suspended particles. These are the volumetric concentrations of sulfur dioxide, nitrogen oxides, carbon monoxide, ozone, and particulate matter. And the latter, although they are reported hourly, there are daily limits that are averaged, and mass deposition rates, dustfall, which is generally measured on a monthly basis. And as Ms. Liffelink has pointed out correctly, that by measuring monthly, it smears out the short-term episodes during which the highest dust falls concerned, and I may come back to that. Now, in addition to routine monitoring of widespread pollutants, this obviously doesn't address all issues. If you've got concentrated sources, you need specialized sampling and analysis of identified hazardous components. For instance, if you've got a lead smelter or a chrome plating operation emitting chrome-6, then you can't say, well, it complies with the general criteria. You need to sample and control those specific components. Sorry. And let me emphasize again that monitoring is always an indicator representing a minute sample of an atmosphere or area. Okay, we also need to consider what monitoring is not. And monitoring is not a substitute for health risk assessments. That needs to be emphasized. That you can say, well, there have been complaints about health. Well, it used to be in the old days, including from the Department of Health, that would say, well, we put up a monitoring as though that solved the problem. Alternatively, a health risk assessment need not be done for every location of a tailing storage facility. So this is a common thing in academia, and perhaps Raisa will confirm this for me, that students, bright-eyed and eager, come say, I want to do a health risk assessment study of mine tailings, because it's a big health problem. And I say, well, what's your background? You say, well, geography or environmental sciences. Say, we've got any medical expertise? No, but I want to do a health risk assessment. And Jill Nelson has explained to us very persuasively just exactly how difficult it is to do health risk assessments. It is not for amateurs or for the faint-hearted, and it's certainly not for geographers and environmental scientists like myself who do not have medical experience to venture into the field of health risk assessments. Charlene will attest to her own challenging path to do those biological response assessments of the ore. So, secondly, monitoring does not directly reduce hazard, exposure, or risk, and that is not its intention. More monitoring does not reduce exposure or risk. So this is direct response to Benchmark Foundation, just adding a more sophisticated monitor that measures things at 1 minute intervals and 20 parameters is not going to reduce the risk, or alternatively, it's not necessarily going to give you any better management information. As you, Jenny, you pointed out at the end of the last talk, we now well know the many of the health risks that inhalation of excess of dust and some of its specific components is not healthy. We might not know all the causal steps, but ask the mother of any infant whether it's healthy to have sand in the child's eyes or the nose where the infant is not yet able to clear its own nasal passages. You don't have to go further than that to advanced science to prove that excess dust poses a health hazard to at least some members of the population. So for the environmental scientists like myself, it's not the health issues, but can you monitor it? And then, as you've correctly pointed out, what can we do about it? Okay, so monitoring with alternative parameters, e.g. heavy metal composition, PM 2.5, with a higher frequency hourly or daily, does not necessarily improve your ability to manage the dust emissions. Okay, so monitoring of dust on the Highveld gold mines. What properties to measure for dust emissions from the gold mines? Okay, there's hazards, there's particulate matter, and the four possible classifications. And I'd just like to ask Raisa to answer later when she was talking about total suspended particulates earlier. Is she referring to particles less than 30 microns, or is she referring to the full spectrum that is contained in dust fall? There's silica quartz, which you just need to take a sample of any mine tailings to measure it. It's got 80 to 90% silica quartz, so you don't have to sample in the air and do complicated analysis. You know what the source material there. It's in 600 million tons, 6 billion tons. You can go and take a small sample to establish that it's silica quartz. There's an iron pyrite, up 2 to 5% of the dumps. There's some elements that are a higher concentration than average crustal soil, and nobody has mentioned this before. There's a little bit of everything in everything. The benchmark, yeah, are these elements enriched in the gold mine tailings relative to average crustal rock? And the answer is that certainly gold is. Arsenic is the key heavy metal that is enriched by 50 to 100 times more than it occurs in average crustal rocks. So that is a significant enrichment, and lower enrichments of lead, uranium, and mercury. Cyanide is used in processing, and on fresh depositions, it's possible for hydrogen cyanide to be emitted as a diffuse gas from the surfaces, and has been pointed out, radon can be released from the radioactivity. The radioactivity, by the way, as Mariette has mentioned, the publications of Hank Coetzee measured the water mobilization of radon daughters is a far more important release of radioactivity from mine tailings than the airborne route. Okay, which of these parameters is useful for the management purposes? And in terms of the national dust control regulations, they require monitoring using a low-cost sampler, and in a session, special session of DEF and NACA yesterday, we had a whole seminar on low-cost samplers, and dustfall monitoring is a dustfall buckets are the ultimate low-cost sampler, which have been in use since 1985, and there are limits that are placed on the dustfall in the rate of milligrams per meter squared per day, 30-day average for residential and non-residential areas. Okay, the methodology is to use a 5-liter plastic bucket supported 2 meters above surface level, a wire frame around it to prevent birds from perching on the edge of the bucket and doing their business into the bucket to reduce contamination, biogenic contamination, and then the sample is filtered. And for the gold mine tailings, it's assumed that the material is insoluble, so you just weigh the dried filter samples to obtain the deposition rate of dustfall. By the way, the sampling method is less useful at coastal locations such as Saldanha Bay, Richards Bay Coal Terminal, where the winds are very much higher, and these samplers are not very efficient at capturing dust at very high windfall. At my own cost, I set up a site at Saldanha Bay and measured more red dust on the outside of the bucket than ever fell into the buckets. On the slightly calmer wind conditions of the Highveld, this has turned out to be a good method. Okay, just to show you why this low-cost sampler has advantages. It allows deployment at multiple sites. So just at the central Witwatersrand, you can see these sampling network around the dumps that are operated starting in 1981. And you can see a very dense spatial network. And while the sampling period is rather long, 1 month, it's complemented by high spatial density. And given that these mine tailings and the sampling sites are often in remote areas and security is a problem, you don't want to be putting a sophisticated monitoring site that A, requires power, and B, is susceptible to high costs if vandalized. And if one loses a bucket or two, it's just replaced. And nobody except me knows where all 80 of those sites are going, and can't contaminate all 80 sites consistently and credibly in 1 month, 1 day. So if somebody puts a rock in a bucket, you know immediately it's been contaminated. So there's a great advantage. It's robust, it doesn't need power, it's low cost, and it can be unobtrusively be placed in residential plots in remote areas and extensive spatial networks.
Sorry, Harold, I'm going to have to ask you to wrap up because we're running completely out of our 2 hours. So we're going to have to close off in a minute.
Okay. Reliability. We currently have over 95% data recovery from these samplers. So reliability is another factor. Yesterday, we reported in some of the NACA proceedings the difficulties that DEF and the whole national network has with PMs and other monitoring houses maintaining reliability, whereas dustfall buckets are regularly getting over 95%. So access to data is important. We've been running a quarterly dust forum open to all interested and affected parties for over 37 years, and all data is made available to the public or to these interested and affected parties without restriction. There's a sample. Okay, the exceedance reporting, I'll skip over that. A quick case study because it's important. This is what the Ergo dump, Brakpan tailings facility in near Brakpan looked like in 2005. You see the extensive bare area and the nearby township of Tsakani. The current operation, oops, sorry, it's jumping. In 2019, you can see that sorry, that's not me doing it. 2019, the surfaces are grassed almost to the top, and the small dump to the left is totally grass over the top. And you'll see the yellow stars indicating the sampling sites. That's what the monthly dustfall looks like, very messy signal, some trend, but it's hard to make out. So we've done a time series analysis separating the seasonal effects, which many people have referred to the windy season, where you get high dustfall. But if you extract that seasonal dustfall and you see an underlying trend in the brown line, and you see from 2009 onwards, it appears that there is a distinct reduction in dustfall, and then a further reduction from 2017 onwards at 3 of the sites, and it's shown in many other sites there and in central Witwatersrand. This is not an accident. It is due to the action of the management of the dump. Ergo Gold took over those operations of the East Rand from Anglo American in 2017. By 2009, their new grassing project was in operation. Yesterday at the award ceremony, the Golden Award for Lifetime Contribution to the Cause of Clean Air was given to Louis Kleinhans, the environmental manager of Ergo Gold, for managing this process of dust suppression. Now, you've asked what can be done about it, and Mayor Marnus reported on the legal aspects and the difficulties. And let me put out a challenging thought that there are possibly 4 people in this industry who, if you got them into the room, could, as demonstrated on Ergo, provide the solution. A, by removing the smaller dumps permanently and so they can pass muster for the National Nuclear Regulatory Agency that there's no residual activity, so it removes the problem at source and deposits it on a super dump that is properly managed. And you can see that it is possible to operate these huge mega dumps with dramatically reduced dust emissions if given the opportunity, as Louis Kleinhans has managed. He's changed his corporate culture from reluctant compliance with the regulations to enthusiastic adoption of best practice in the industry. And that is why he was given the award. And if you get those 4 people, Louis Kleinhans, Greg Othens, Dave Rhodes, and Andrew Barker, possibly Jenny and myself into a room, we could devise a medium and long-term strategy to effectively reduce the hazards and risks from dust emissions from gold mine tailings. Thank you.
Thank you so much, Harold. I like the way you ended that. I think that this has come through very, very strongly today. And we unfortunately really run out of time. There's been such a wealth of information. I haven't wanted to stop this. But I think that the take-home message is, well, yes, we could do more and more monitoring, more and more measurements, get more and more evidence. Easier said than done. There's a lot of challenges with getting this type of evidence. And really, we know that these dumps contain hazardous materials. We know that this material is getting dispersed to the environment. We know that there's plenty of anecdotal evidence that the stuff is causing health issues to local communities. The law, what is concerning the law, doesn't seem to be able to deal with the complexities of past operations, current operations, and the future going forward. And even worse, there doesn't seem to be a will to do anything. So I think that this is where we really need to, rather than just collecting more and more evidence, we need, and this has came across time and time from every one of our panelists, it's time for action. We've got to decide what solutions we're looking for, and we've got to get them. We've got to actually address the problems that there clearly are. Any burning questions? We've kind of run out of time. Ure's just posted. There's been some active chats on the side. Ure's just posted. If you want to continue with us on this conversation, we will be taking this further. One of the things I want to look at with some of our partners is how can we push for some kind of consolidated response to these concerns and the evidence that has already been produced. Please go to our website, minedust.org. If you want to join us on this trip, I see Rudolph has already said he wants to be in the room. And Harold's mentioned some other names of influential people. We will, and yes, Clinton, undergraduates are definitely still allowed to join. So please, I think that if united, what do they say, together we can, this collaborative effort, pulling our knowledge together and striving forward to get some kind of response. And it's not going to be one single response. There's past legacy issues that need to be dealt with, that there needs to be compensation. We need to stop making sure that there's going to be legacy issues down the line as well. Claire Gwyn's just added the link to our website, and where you can contact us if you want to be part of this group and the conversations going forward. And just more than conversations, I think we're going to try and get some collective action to address this issue. Anything anybody would like to say to finalize? Yure, our network manager, would you like to say a few words quickly?
I'll just reiterate what I said yesterday with the little sponsorship talk. Please get involved, have a look at our website, look at our events, and come join the conversation, because it is by collaboration we will find, or we have the most chance of finding solutions to these things. Whether you're an environmentalist, geographer, health scientist, it's by putting minds together that I think is what has shown this network, and I mean many other collaborations have shown that it's really successful. So have a look at our website and get in touch. Thanks.
Yeah, what we'll do is we'll form, you're all welcome to join our network. It's open. We'll also look at forming a working group around the particular case study of gold tailings and dust from gold tailings. Thank you very much. Thank you. And I guess before we all get kicked off, I better actually close the meeting. Anybody want to say last chance? Anybody want to put up their hands? I can't see any hands up. Anyone want to just quickly say, Natasha, there's a hand up, please.
Hi, yes, can you hear me?
Yes, we can hear you.
I just wanted to get I did make a comment about a study I did for the career run tailings, where I also used AirMod, and my results actually looked a lot like hers. So if we can maybe talk about that offline, you can maybe just read my comments.
I see it there, yes. Okay, absolutely. I'm glad to see the conversations and people getting together on the side. People have been involved in community monitoring and exposure monitoring. So please, either via us or directly get in touch with each other around that. We'd be really interested, Natasha, in you joining this group and bringing your studies to the table as well. Thank you. Okay, I don't see any other hands, and I think we're about to get kicked off. All right, thank you very much, everybody, for joining us, and let's see how we can take this conversation forward. Thank you.